time in minutes it takes for someone to turn into a zombie after being bitten is best modeled using a normal curve with the following parameters. Mu equals 45, standard deviation equals 5. 3 questions. What is being modeled? What is the random variable? What does the data set look like? Number 1. What is being modeled? We are modeling time. The question is, how long will it take somebody, when they get bitten by a zombie, to turn into a zombie? Very typical question. And the answer is, we don't know. But the time itself, which we'll call x, is predictable. It's predictable overall. It follows a known pattern, and that pattern is the normal distribution, a normal curve. So what's being modeled is time. That is the random variable, time. 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 X equals time. Time in minutes. What does the data set look like? We have mu equals 45 and sigma equals 5. Right, where do those things come from? Here's the answer. The answer is we have a data set here with many observations. We have subject ID 0001, and it took them 47 minutes to turn into a zombie. The next person took 39 minutes, then 53 minutes, and then so on and so forth. When you add up all of these and divide by 1,000, you get the average, which is 45. What does mu equals 45 mean? What does sigma equals 5 mean?
Mu equals 45 means if you added up all of the observations, which are 1,000, there's 1,000 different x values, and divided by n, which is 1,000 in this case, which is the number of individuals that are being experimented on with this new zombie antidote, whatever it is.
We get 45. And 45 is our measure of center for this data set. That gives us an idea of typically what will happen. So we don't know how long it will take for Bob to turn into a zombie. We know that on average, though, it takes 45 minutes. Now, just knowing what is most typical isn't enough. What we need to know is the spread. And the spread here is the standard deviation, and that value in this problem is 5. The standard deviation is calculated as follows. What we're going to do is add up all of the x's and then divide by however many we have. We want to know how far are those on average from the mean. So the notation is x minus mu. And then what we're going to do is square those deviations, and then we have to take the square root. A lot of work to be done here. That gives us the standard deviation. It's a measure of spread that we use for the empirical rule. What is the center? The center here is the mean. This is 45 minutes. What is the spread? This is the standard deviation. This is 5 minutes. What is the shape? This is the normal distribution. This is the probability model that we're using to try and get an idea of how long it's going to take for somebody to turn into a zombie. The time in minutes it takes for someone to turn into a zombie after being bitten is best modeled using a normal curve with the following parameters. Mu equals 45, standard deviation equals 5. What is the empirical rule, and how does it play into this problem? What is the empirical rule? What is the empirical rule? What is the empirical rule? The word empirical means evidence-based. From our observations of the world, we have some variable, x, that is modeled with a normal distribution. Modeled, as in, this is the best way we can predict the outcome. If we know x follows a normal distribution, knowing the mean and knowing the standard deviation is really helpful for us, center and the spread. So about 68% of everything in the data set will be within one standard deviation of the mean. About 95% will be within 2 standard deviations of the mean. 2 standard deviations of the mean. So if you think about this curve as being 100% of things, whatever it is, about 68% of things will happen within 1 standard deviation, and about 95% within 2 standard deviations. From there, what we can do is use the symmetry of the curve and chop the 68% in half. And what we see is that if we have the mean right here, and we consider moving along the x-axis using standard deviations, we know about 68% are within 1 standard deviation. That means if we move 1 standard deviation to the right and we move 1 standard deviation to the left, we get 68%. 68% divided by 2 gives you 34%. As such, about 95% are within 2 standard deviations of the mean. And basically everything is within 3 standard deviations of the mean. This is the empirical rule. The time in minutes it takes for someone to turn into a zombie after being bitten is best modeled using a normal curve with the parameters mu equals 45 and standard deviation equals 5. Consider, what does the empirical rule say about the following? The percentage of people taking between 40 and 50 minutes to turn into a zombie. The percentage of people taking between 35 and 55 minutes to turn into a zombie. The percentage of people taking between 30 and 60 minutes to turn into a zombie. How can we use the empirical rule in this application to answer these questions? Consider the percentage taking between 40 and 50 minutes to turn into a zombie. What does the empirical rule say? Well, the empirical rule says that about 68% of people will turn into a zombie somewhere in the interval of 40 to 50 minutes. Let me show you with the picture. Draw a normal curve and identify the mean, which is 45, and then walk out a standard deviation to the left and then walk out a standard deviation to the right. And what you get is 40 as a lower bound and 50 as an upper bound. What the empirical rule says is about 68% of all x values will be within 1 standard deviation of the mean. About 95% of people will turn into zombies within 2 standard deviations of the mean. So that is all the way down to 35 minutes and all the way up to 55 minutes. 2 standard deviations below, 2 standard deviations above. That's 95%. 95% of all x values will be within 2 standard deviations of the mean. 99.7% will be within 3 standard deviations of the mean. If you have somebody that gets bit by a zombie and you're thinking, wow, I wonder if it'll take 70 minutes for them to turn into a zombie, then you're probably in really, really bad shape. It's about 99.7% will turn into a zombie within 30 minutes, which is 3 standard deviations below, and 60 minutes, which is 3 standard deviations above.